Good afternoon, everyone. I'm very pleased to talk to you today about our research to find out how climate change will affect biological communities. And the communities we work with are composed of macrobenthos species, which are those invertebrates larger than 1 millimeter in size that live in and on the seafloor and can be highly abundant in coastal seas. And these organisms have a variety of traits which are often related to where they live exactly and how they feed. For example, this little mud snail here crawls over the seafloor grazing on benthic microalgae. Others, like this large clam, Scrobicularia plana, is not that mobile at all, but is extending its siphons into the water column to obtain food via suspension feeding. Others, like this ragworm, are more mobile, creating these gallery burrow systems in search for prey and therewith strongly ventilating the seafloor. And by doing all these activities, all these species interact with each other directly but also indirectly via their effects on their environments. If, for example, we take a typical sandflat community where those three species I just introduced you to make up the major part of the macrobenthic biomass, we know that the ragworm, the activity of the ragworm is making nutrients more available for microalgae to grow, but also that the same ragworm is consuming the microalgae. We also know that this large clam is actually reducing the effects of the ragworm via interference competition effects. And together with a lot of other interactions, this is how an ecosystem interaction network under ambient conditions looks like. So, and what we wanted to find out is how these community interactions might change along with ocean warming and acidification. So to do that, we brought these communities into the lab where we can experimentally mimic those warm and acid future conditions, and we looked into how the network structure was changing. And what we found was that under future ocean conditions, the network looks much more simple. It's much more simple. And in particular, the interactions in which the clam is involved disappear or change. The clam is the clam is no longer affecting the ragworm. It's no longer depleting nutrients, and it rather stimulates microalgal growth. So, but why is that? And to find that out, we decided to look into the behavior of this clam specifically. And to do that, we used pressure sensors that we insert into the sediment and enable us to link specific changes in the pore water hydraulic to specific activities performed by that clam. And what we found is that that clam is actually shifting from suspension feeding towards deposit feeding with ocean acidification and warming. But why is this clam doing that? Well, we believe it's doing that because as it is deposit feeding, it's actually feeding in an environment which is less acid than the water column. And marine sediments have a higher buffering capacity towards pH change than the water column. In addition, as a deposit feeding event is shorter in time and occurs with a lower pressurization, it means that in the end the clam takes in less water. And it is exactly this lower pressure that is generated during deposit feeding that we believe is responsible for the removal of that competition effect with the ragworm. And this indirectly stimulates microalgal growth together with the nutritious biodeposits that are produced during deposit feeding. And this might be very well the reason why we found that herbivore species from different taxonomic groups might be more vulnerable, more tolerant to climate change and ocean acidification when the clam is present in comparison to the clam when the clam is absent. So what this means is that if we're going to lose large telenid bivalves, this might aggravate species vulnerability to climate change. And from a more general angle, it means that if we really want to understand and predict better how climate change is going to affect marine ecosystems, we definitely have to start considering non-lethal effects, such as behavioral plasticity, that can have cascading effects on ecosystem resilience, community interactions. With these two take-home messages, I would like to thank you for your attention. And if you're interested to use our experimental facilities, don't hesitate to contact.